Preparation of alcohols. There are 4 ways to prepare alcohols, which are fermentation, hydration of alkenes, hydrolysis of haloalkanes, addition of Grignard reagent to carbonyl compound. Let's look at fermentation of carbohydrate. Fermentation is a biological process in which microorganisms, yeast, act on sugar to produce ethanol and carbon dioxide. So this is the first way to prepare alcohol, fermentation. We have glucose in the presence of yeast. This is a kind of microorganism, and it will produce alcohol ethanol. 2 ethanol will be produced if you have 1 molecule of glucose. 2 alcohol will be produced and 2 carbon dioxide is produced as well. Next, second way to prepare alcohol is through hydration of alkenes. The reactant must be alkene and water in the presence of catalyst H2SO4. This is addition reaction. We have to follow Markovnikov's rule. So alkenes react with water in the presence of sulfuric acid H2SO4. 1 hydrogen is added to the carbon, one of the carbon double bond, and OH group is added to another carbon double bond. We have to follow Markovnikov's rule, means hydrogen will be added to the carbon that has higher number of hydrogen. That is Markovnikov's rule. In addition reaction, hydrogen will be added to the carbon that has higher hydrogen atom, and it will produce alcohol. This is the second way to prepare alcohol. The third way to prepare alcohol is hydrolysis of haloalkanes. Means we have haloalkane or alkyl halide reactant. We react it with NaOH or H2O, but the name is hydrolysis, so usually we react it with the water. Okay, we can also use NaOH as well. So we have haloalkane, for example, bromoethane here reacts with NaOH. The OH will be replace the Br. OH will replace the Br, and here alcohol will produce an NaBr. The hydrolysis of haloalkane, this is alkyl halide, reacts with water. The OH in water will replace this halogen, so it becomes 2-methyl-2-propanol, and the side product is this hydrogen from the water and Cl halogen from here. So this is the side product. Next, the final way to prepare alcohol is addition of Grignard reagent to carbonyl compounds. Primary, secondary, and tertiary alcohols can be prepared by addition of Grignard reagent with carbonyl compounds followed by hydrolysis. So you have to know you want to prepare primary, secondary, or tertiary, because the way in preparing different classes of alcohols are different. Okay, so we have aldehyde or ketone. Okay, aldehyde or ketone, it depends on the class of alcohol that you want to produce. Reacts with Grignard reagent. So how to prepare Grignard reagent? This R group with halogen. This X is halogen atom. R group with halogen. Reacts with Mg, the presence of dry ether, magnesium in the presence of dry ether, and Grignard reagent will be produced. So this Grignard reagent reacts with aldehyde or ketone, depends on the class of alcohol you want to produce. First, react with ether in the presence of ether, followed by acidified water. H2OH plus means H3O plus, and primary, secondary, or tertiary alcohol will be produced. Let's look at one by one. If we want to form the primary alcohol, Initially, make the Grignard reagent first. Rx, X is the halogen, reacts with magnesium in the presence of dry ether, and there you are, your Grignard reagent. So this Grignard reagent reacts with methanol. This is aldehyde with one carbon only. This carbon has hydrogen and hydrogen. This carbon has no other carbon attached to it. Okay, if the Grignard reagent reacts with the methanol in the presence of ether, followed by acidified water here. Okay, followed by acidified water. So this is step by step. Okay, step by step. First, if you react with ether, this R will attach to the carbon over here. The R of the Grignard reagent will form bond with the carbon here, R delta minus, this carbon delta plus. So R as nucleophile, attack here electrophile, and the carbon-carbon double bond over here, carbon-oxygen double bond over here, it used one of the bond to give two lone pair electron to the oxygen over here, and it will form OMGX. This MGX delta plus, and then will form OMGX over here when you react with ether, and R group is bonded to the carbon delta plus here. Okay, and then after that you react with acidified water, then this MGX will be replaced with the hydrogen of the acidified water over here. So this is primary alcohol because this carbon is attached to one alkyl group only. So this carbon attached to one alkyl group means this is a primary carbon. So this OH attached to primary carbon, so this is the primary alcohol. Means if you want to form primary alcohol, the Grignard reagent must react with methanol, specific aldehyde methanol. Okay, aldehyde with one carbon only. That's if you want to form the primary alcohol. Okay, this is the example of the R group. For example, we have 4 carbon in total here, alkyl halide. Okay, 4 carbon alkyl halide reacts with Mg and dry ether to form Grignard reagent, 4 carbon MgCl. Okay, make sure the Mg is bonded to C. The Mg is bonded to C, not Cl. So this is the Grignard reagent. Reacts with methanol, or formaldehyde is its common name. The common name of methanol is formaldehyde. Okay, so it reacts with methanol or formaldehyde in the presence of ether, O minus MgCl plus. So this plus is for MgCl, O minus is this O, because this double bond over here, one of the bond is used to give the lone pair to this electron, making this O negative, and MgCl here is delta plus, O minus MgCl plus, the plus at the Mg over here will be produced, and then it will follow by the reaction with acidified water, H2OH plus or H3O plus. The hydrogen will be replaced the MgCl, making this OH group attached to the carbon. So this is the primary alcohol because OH group attached to the primary carbon. So this is how the formation of primary alcohol using Grignard reagent and methanol or aldehyde with one carbon only. Methanol, formaldehyde is the common name for methanol. Next, formation of secondary alcohol. In order to form secondary alcohol, we use Grignard reagent and aldehyde. But the aldehyde here is not methanol. It is aldehyde with one R group attached to the carbon. So initially you have to make the Grignard reagent first, and then these are minus as nucleophile attack C delta plus over here, and it will form bond RC. One single bond is formed in the presence of ether, and then the double bond C double bond O, one of the bond is used to make lone pair at the oxygen, okay, making this oxygen negatively charged, so Mgx delta plus, and it will form O minus Mgx plus. The plus is at Mg, and then follows by the reaction with acidified water, and this Mgx will be replaced with hydrogen H, so it will form the alcohol over here, and this is secondary alcohol because one R from Grignard reagent, another R is already at the aldehyde. So the product is secondary alcohol because OH group attached to the secondary carbon, so this is secondary alcohol. This is the example of formation of secondary alcohol. Initially start with formation of Grignard reagent. Okay, hello alkane reacts with Mg in the presence of dry ether. This is the Grignard reagent. And then we use aldehyde with one R group over here, C double bond O, one R group over here. Aldehyde we use is acetaldehyde or ethanol. Acetaldehyde is a common name. The IUPAC name for acetaldehyde is ethanol because we have two carbons in total. So this ethanol or acetaldehyde in the presence of ether reacts with Grignard reagent over here, O minus MgBr plus. So this bond will be used to form lone pair oxygen, and then this Mg plus O minus. This is the product, followed by reaction with H3O plus, and then the H plus will replace the MgBr, making the secondary alcohol over here. The OH attached to carbon, that is secondary carbon. This is the secondary carbon. So this is the formation of secondary alcohol. Next, formation of tertiary alcohol. Tertiary alcohol use Grignard reagent and then reacts with ketone. For tertiary alcohol, make sure to react with ketone. Primary, secondary alcohol formation react with aldehyde, but for tertiary alcohol, we react with ketone in the presence of ether, and then this R group over here will form bond with the ketone carbon. Okay, carbonyl carbon in ketone will form single bond, and then next reacts with acidified water to form tertiary alcohol over here because OH group attached to tertiary carbon. This carbon has 3 R groups attached, so this is tertiary alcohol. Example over here we have Grignard reagent. This is Grignard reagent reacts with ketone, and the R group over here, take all this R group over here attached to this carbon, so this is the single bond attached, and then the Mgx delta plus will react with O minus here. Why O minus? Because one bond is used to form the lone pair at the oxygen, so O minus Mg plus X, and then the reaction continues with acidified water, and this Mgx will be replaced by H, making the OH group attached to this tertiary alcohol. This is tertiary alcohol.